In this course, you will learn how to upgrade the entire full stack application for the Raspberry Pi, and that includes not just the software side, but also the hardware side. That's because from the time that the original Raspberry Pi full stack application was published, there has been advances in the hardware side with new Raspberry Pi computers and new microcontrollers on the other side for the remote node. So in this section, I want to give you an overview of the hardware that I'll be using and that I recommend that you also use for your Raspberry Pi full stack application upgrade. The thing to remember here, and I'm going to go more into this later on in follow-up lectures, is that you have actually a lot of flexibility in terms of the hardware that you can go about using. And I'll give you some options in this lecture as well. I'm going to start with the Raspberry Pi, which is going to be the host for the application itself. And then later on in this section, I'll talk about the hardware that we'll be using on the remote node. So let's talk a little bit about the Raspberry Pi. In the original version of the Raspberry Pi full stack, I remember back in 2016, I believe, I used an original Raspberry Pi Model B. Since that time, I've also implemented the Raspberry Pi full stack application on a Raspberry Pi 2, Raspberry Pi 3, and Raspberry Pi 4. Now, the Raspberry Pi 4 is an excellent computer. The problem is that it is a little expensive and it is overpowered for the type of application that the Raspberry Pi full stack application is. We don't need any graphics acceleration, for example, so we don't really need any capabilities on that front. The memory footprint for the full stack application is quite low, so we don't need, say, a 4 gigabyte computer. And I think that a much better option for the Raspberry Pi computer is a new Raspberry Pi Zero 2W that came out a bit earlier this year in 2022. So the great thing about the Raspberry Pi Zero 2 is that it does have wireless, so we can use the local Wi-Fi network to connect to the Raspberry Pi, and it's got a full set of pins on its header. It's got the same configuration of the header as the Raspberry Pi 4, so no problems there. And it's got a new quad-core microprocessor, the RP3A0. Just more about this in a moment. The other really nice thing about this option, the Raspberry Pi Zero 2W, is its price. Just $15, at least that's its sticker price. It may vary depending on where you get it from, but it is a fraction of the cost of the Raspberry Pi 4, even the 1 gigabyte model. So in terms of technical specifications, you see there's plenty of power here. Your application will run very quickly. Installation of packages and any compilation that we need to do will also happen very quickly. Half a gigabyte of memory, more than enough. In my experiments, looking at the operation of the full stack application on this memory, it really only occupies part of that memory, leaving plenty of room to grow. No problems with all of the various types of Wi-Fi protocols. 802.11, BG, and N is all possible. And everything else is standard Raspberry Pi hardware. So we are all covered here. If you happen to have another Raspberry Pi available, of course, you don't have to go out and buy a Raspberry Pi Zero 2W. As I said, really the full stack application is not demanding on the Raspberry Pi side. You can use any Raspberry Pi 4 or even an older Raspberry Pi. We are only going to be using part of the pins on the header. Now, in terms of hardware with the Raspberry Pi, the only requirements is some means of Ethernet or Wi-Fi communications. So, for example, you can go for a Raspberry Pi 3 that has Ethernet only but no Wi-Fi. That's going to work, no problems, so that we can access the Raspberry Pi from our main computer via the web browser and through SSH. We also need I2C for the OLED display and the sensor, and the UART channel for the HC12 transceiver module. And all of the Raspberry Pis, going back to the original, have those features available. So that's about it with the Raspberry Pi hardware. In the next 2 lectures, I'm going to show you how to install the Raspberry Pi OS on your SD card. That will go into the Raspberry Pi itself. And after that, I'll show you how to prepare the infrastructure on the software side for the application. I'll show you how to turn on the communications protocols, in particular UART serial and I2C. Towards the end of this section, I'm going to talk a little bit about the ESP32, which is the board that I'll be using to implement the remote node for the full stack application, where you also have quite a bit of choice as well. You don't have to use the ESP32. For example, you can even use an Arduino Uno or any microcontroller that is compatible with the Arduino IDE that has a spare I2C and UART interface, or with the Arduino Uno, you can even use a software serial port as well. So plenty of flexibility there as well. Okay, so let's continue in the next lecture where we'll install the Raspberry Pi OS.